Okay, good morning, everybody. So we're in our last example in the last notebook that we're covering this year in this course, or this term. So in the last lecture, we were looking at manipulating the file position directly using commands like fseek, so that lets you move to a position in the file. You can get a position from the file using up here using ftell. You can rewind a file, so go back to the beginning of the file using rewind. And so today we want to look at another example of using or manipulating the file position to perform some kind of task. So if you wanted to replace every occurrence of a character in a file, you can write a little program that will do this. And so the program is shown to you here in the notebook. So to use the program, you need the name of the program. You need to tell it what file do you want the program to replace the characters in. You have to tell the program what character do you want to replace. And of course, you have to tell the program what character are you replacing with. Right, so the input to this program requires three inputs. Now remember in C, argc and argv, argc is the number of command line arguments plus 1. The plus 1 comes from the fact that the first or the 0th value stored in argv is always the name of the program. More precisely, it's how you invoked the program. So if you invoked it from a different directory, it includes the path from which you called the program. So argv 1, 2, and 3, and so on. So your first argument is in argv 1, your second command line argument is in argv 2, and so on and so on and so forth. So this program actually checks if we have the right number of command line arguments. Right? We need 3, so we check if there's 4. If there isn't 4, that's a problem. Right? Okay, so assuming we have 4, this program leaves out the error checking to keep things simple. We're going to open up the target file. So remember, the target file was the first command line argument supplied to the program. Also remember that your command line arguments are supplied as an array of strings. Right? So I want the second command line argument is the name of my file, so that's just argv1. We want to, here we want to open the file. We want to read characters from the file. When we find a character that we want to replace, we want to write that character back into the file. And so this is the first example, and the only example, where we open a file for reading and writing. So here we're going to open it up in R+ mode. Right? We don't want W+ mode in this case. Right? W+ mode will overwrite the file. Right? It clears the contents and then starts writing to the file. We don't want A+ mode, that also overwrites, that appends to the end of the file. We want to read from the beginning of the file, writing into the position where we tell it to write into. Okay, we next need the character that we want to replace. So that's sitting in argv2, right? The third argument to the program. But we only want the first character, right? So if they give us a string, we're just going to ignore all the other characters in the string. So what we really want is we want the first character from the third argument, right? So that's why there's a double indexing happening here. The replacement character, well, that showed up in the fourth argument. Again, it gets passed to us as a string. I only want the first character of the string, so I want the first character from the fourth command line argument. So that's my replacement character. Now you want to read the file one character at a time. Right? You could do this other ways as well, right? You could read this a line at a time, and then scan the lines, and then try to replace the lines. Does that work? You can make it work. It's awkward to do it that way. So this one, it's easier to read and replace as you need to. Okay, so here we have the standard read a file one character at a time loop, right? If you want to read a file one character at a time, it always looks something like that. Right? So that reads the character into C. Right? If we find a character that we are interested in overwriting, so in other words, if C is the target character, we need to overwrite the target character. If we see any other character, we don't care, right? We don't want to touch the file at that location. So if if the if statement condition is not true, just read the next character. All right, so if we find the target character, remember what fgetC does? It reads the character, advances it to advances the file position to the next position in the file. So to overwrite the character we just read in, we have to back up one position. So here we use fseek. on the file F. Right? We're going to back up one position from the current location in the file. Right? So seek cur means the current file position. So back up one position. We're now at the character that we just read in. Now we can use fputc to replace the character in the file F. Right? Like that. And so that overwrites the character that we read in the previous step. Right? When you write the character, it goes to the next character. It advances the file position one position forward. Right? Now, to make your program strictly correct, you need to flush the buffer here. There's a reason for this. It's down here. So a file position operation or fflush must be called between a write operation and a subsequent read operation. So you're not supposed to write something into the file and then immediately try to read something from the file. You need to either reset the file position somehow, so call fseek after fput, right? Because the next thing we're going to do is we're going to read something from the file, right? Your other option is to flush the buffer, which forces the operating system to write the contents it forces the operating system to write the contents to disk. Right? So you have to do one of those. If you run this program without fflush there, it usually works. Or at least it always works as far as I can tell. But the standard says you should really flush you either flush the buffer or reset the file position somehow. So if we try this program out, where is this located? This is going to be, I'm in the wrong directory, so I have to move to the correct directory. Oh, sorry, bear with me. I think this is IO, and so this is is it here? Sorry, what did I replace? Car. I forgot where I put it, sorry. Oh, it's not here. I guess we're not going to run it. Okay, hang on, bear with me. I'm just going to copy this and create the file now. Oops. Hopefully this works. Oh, it put in, oh, that didn't work at all. Sorry. Why did it put in the, okay, better. I hope. Okay, so let's look at alphabet. Okay, so alphabet is just the alphabet, the lowercase English alphabet. So let's replace something in the alphabet. So let's replace the J with the uppercase J. All right, and that works. Perfect. All right, so there are some important things about this example here. All right, so the first important thing to mention is that there's no way that you can, so this program replaces a single character at a time, right? If you wanted to, you could replace a string at a time, but you can only replace the string with an equal length string. And this is because files are just streams of data, right? So imagine it's an array of data. And so you can write into any one position in the file, right? You can read into any one position in the file, but there's no way to insert something into the middle of the file, right? If you wanted to insert something into the middle of an array, you'd have to move all the other elements down past the insertion point, right? Similarly, there's no way to remove a character from a file, right? So I can't delete a character without leaving another character there, right? The same thing happens in an array. You can't remove an element from the array without shifting all the other elements forward in the array. So there are no operations that let you insert or remove from anywhere in the file itself. You can remove at the end, of course, and you can add at the end, but there's no way to easily do it in the middle of the file. So if you wanted to do something like remove characters from a file or insert into the middle into a file, you can either use one of the command line tools that are available to you. So there's a program called SED, which is a stream editor, which is designed for editing streams of data. Or you could, if you wanted to write your own program, one of the strategies would be to read the entire file into memory, perform the manipulations in memory, and then write the contents back out. Right? So that would be one. That would be a possible solution. You could also read. So read characters in, write them if you don't want to replace them. When you find a character or characters that you want to replace, you then have to remember that you're going to delay writing until you replace the characters and then continue reading. Right? So there's more bookkeeping that you would have to do to perform operations like that. All right, so that is the last notebook that is written for the course at this point in time. And so we have a bunch of lectures left. And so I guess what we should do is try to put everything that we've learned into practice. So this is a systems programming tool, so it makes sense to write tools that someone might want to use on an operating system. So for example, can we implement the copy, the copy program? Right? And so to copy a file, conceptually what you want to do is you want to read every character of the file and you want to write it back out to another file somewhere. Right? And so we know how to read a file one character at a time. We know how to read it one line at a time. It seems like you ought to be able to pretty easily implement copy, or at least a basic version of copy. Right? And so let's try doing that. All right, so we want a main method. Now, I'm going to write copy so that it reads the file from standard input, or it reads stuff from standard input, and then writes stuff to standard output. Right? So rather than reading directly from a file and writing directly to a file, I'm going to rely on the redirection in order to read and write. Okay, so what I want to do is I want to read standard input one character at a time. Right? Standard input's just a stream or a file, so you can treat it as though it were a file. So you write the standard character-based loop. Right? So int c, that's the character I'm going to read in. Right? So right, to read a file one character at a time, right? C, you use fgetc. Right? You tell it which file do you want to read from. Well, I'd like to read from standard input, so this is just stdin. Right? Okay, so while that does not result in end of EOF, so in other words, while it succeeds, okay, so to use fgetc, I need to include standard IO. So back up here. Include the header. Okay, I now want to write the character I read in to standard output. So I'm going to include the error handling in the first program. I'm going to drop it after this. Okay, so fputc. So I want to write the character C. I want to write it to standard output. So that's just std out. This returns EOF if there's an error. Oh, sorry. Yes, if there's an error. So I'm going to do the error handling right here. Right. So if this fails, we're going to print some error message. Whoa, sorry. So for the file handling functions, you can print an error that occurs using perr. Right? Oh, there's the help for it right there. Right? Print a message describing the meaning of the value of no. Right? Many of the functions in the standard library, the way they indicate an error has occurred is they write into a global variable called errno. Right? And so not all of the standard library functions do this though. So you have to read the documentation to look at the function that you're using to determine whether or not it actually sets no or not. If it does, you can print the error using perr. You can also get the error string using str error. Okay, so that's going to print out that, and then it'll give you some description of what the error actually was. And so if you get an error here, you probably want to exit the program. So I'm going to return with some non-negative, non-zero value. Right? Remember, the return value from main is the exit status of your program. Right? So in Bash, you should exit with a non-zero value if your program has encountered an error. So here I'm going to return with 2. Okay, so when you're reading from the file, you can, reading can also fail. So I guess we should really check if an error had occurred during reading. Okay, so the funny thing with fgetC is that it returns EOF, end of file, if it gets to the end of the file, right? So that's normal. You expect that to happen, right? You're reading a file, one character at a time, eventually you're going to get to the end of the file. So eventually, you want to get EOF. Now the problem is it also returns EOF if it encounters an error. So here, I have to ask, we have to use a standard library function, was there an error that occurred while we were reading standard in? Right? And so that's the ferror function there. Not going to ask you about that on the exam. Similarly, not going to ask you about p-error on the exam, right? But I'm just showing you how to do it here. Right, so print a little error message. It'll also add some extra information about why the error occurred. Right? Again, we encountered an error, so we should return some positive non-zero value. So I'm going to return 1 here. And then this is main, so we should really return 0 here. If you don't return 0, it automatically returns 0 for you. All right, so just to quickly review, what the heck did we just do? Oops, sorry, I should put void in here. All right, so again, read the file 1 character at a time, right? So read from standard in 1 character at a time. Every time we read a character, write the character back out to standard output using fputc. Right. All the other stuff is just error handling, right? So there's really only 2 lines of code in this program, right? And I claim that this will in fact copy any file in Linux, believe it or not. Where did I put this? Sorry. I put this in a different directory. Uh-oh, cd. So it's in here. Okay, so I'm going to compile this. That's great. That normally doesn't happen. All right, so I need to make a file. Some file. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. That's enough. All right, so to use our program, I need to tell it to read from standard input. So I want to redirect the contents of a file to standard input, right? That's the less than sign in Bash. Right, so that's going to, so if I run it like this, all it's going to do is print out the contents of some file to standard output, right? So that's basically cat. Right? If I redirect the output to a copy of some file, right, and look at the copy, right, you see that it in fact has copied the file exactly the way it appeared originally, right? And so in Linux, Linux doesn't care if you have text or if binary data in a file, right? It simply reads stuff in 1 byte at a time. And so this will copy any, I think it'll copy any file in Linux. Right? So you just redirect the contents of the file that you want to copy, redirect the contents back out onto a separate file. Right? It also behaves as cat, right? That's exactly what cat does. If you wanted to, could you do this with more than 1 file? I guess you can. Can you easily redirect more than 1 file? I don't know. So I'm actually not sure. Anyway, if you wanted to make this file-based, right, you could just insert some int argc, carstar argv, square bracket, right, and read your inputs from standard input instead, from the command line instead, right? So there's character-based copying. Now you can also do line-based copying, but line-based copying is a little bit more complicated. right? All right, so this is copying using copying a file one character at a time. So let's do copying a file one line at a time. I'm just going to copy this because the code is pretty similar. All right, so instead of reading one character at a time, we need to read things one line at a time. Now the problem is when you read stuff one line at a time, you have to read it into an array somewhere, right? So we need to make a buffer or an array of characters. So I'm going to declare a constant called max. This is just the maximum line length that we're going to read at it. Sorry, the maximum number of characters that we're going to read at any one time. Right? So I'm going to make it fairly large, so this should be able to handle very long lines. But it turns out it doesn't matter. We're going to write this in a way so that it doesn't matter if you read in an entire line or not. It just keeps on going until it reads in an entire line. So I need to make an array of char that is max long. Right? So that's the buffer that I'm going to store the characters that I read in from. And now I want the standard read in a file one line at a time loop. Right? So that's also a while loop. Right. This time you're going to use fgets, right? So read a line of a file, one line at a time. So fgets does that, right? How do you use it? So the first thing you pass in is where do you want to read the information into? So that's going to be into my buffer, buff, right? How many characters should it read in? -1, or +1, sorry, right? So fgets will read in max -1 characters at the most because it's going to insert the null terminator at the end. Right? Where do you want to read from? Well, I'd like to read from standard in. Right. Okay, so fgets returns, what does it return? So it returns a pointer to, it returns buff, right? It returns a pointer to the first character of your array if it succeeds. Right? And so that lets you pass the result of fgets to some other string handling function if you would like. Right. If it doesn't succeed, it returns null. So here I want to test, is the result not null? Right. If the result's not null, it succeeded. So now I can write whatever I just read in back to standard output. Right. And so to write something to standard output, there's a bunch of ways to do it. Right. You can use, but I'm going to use fputs here. Right. You could also use fprintf. If you use it correctly, you'll get the exact same result. So fputs buff standard out, right? Again, so again, what do you want to write? Well, I'd like to write the contents of the buffer, right? Where do you want to write it to? Well, I'd like to write it standard out. Okay, so fputs returns EOF if it encounters some kind of error. So I said I wasn't going to handle errors, but I guess I'll go do it again. Okay, so this one is now fgets encountered some kind, fputs, sorry, encountered some kind of error, so we'll do that. Right, and it turns out the rest of this is all the same. Oop, there we go. So if reading from standard input also fails, again, we can check, we can call ferror to determine if an error occurred while reading standard input, right, and away you go. Okay, so what happens if this thing doesn't read to the end of the line? Right, so in other words, you have a very, very long line. It's longer than 4,096 characters. Right, so fgets reads up to that many characters -1. Right, so it'll read in 4,095 characters. If it's not the end of the line, the next time fgets gets called, it continues reading from where it left off in the previous step. Right. Fputs writes the contents of that buffer to standard output, but it doesn't insert the new line character at the end. Right. It will insert this, so if the new line character is in the array buff, then it'll write the new line character, right? But it just writes everything up to the first null terminator. So even if you don't read in a complete line, with the first call, with one call to fgets, right? Fputs just writes what it read in. The next time you call fgets, it just continues reading the line. So even files that even have very, very long lines, this program handles just fine. Okay, if I typed in everything correctly, we'll be able to compile this. Okay. And so does this work? So it works the same way as the other one. It's just line-based. So we can look at the sum file. right? It also behaves just like cat, right? At least with one file, right? Can I send the output to copy of some file? Yes, I sure can, right? Is the copy correct? The copy is in fact correct, right? And so there's a different version of implementing a very, very simple form of copy and cat using line-based input. Anybody has any questions, just stop me, stick your hand up, right? Whatever you want to do. All right, so what else can you do if you with this line or character-based input, right? So if you stop and think back of many of the tools that we used when learning Bash, a lot of the tools read some file, did something with the file, right? Did something when reading from the file and produced some output, right? Okay, so one of the tools was cut, right? So cut let us cut a column of data from a file, right? Now to use cut, you have to pass in some some options, right? Typically you pass in which field do you want to cut from, right? So if you have 3 columns of data, you tell it 1, 2, or 3, or 1, 2, or 1, 2, 3, or 1 through 3, or 2, 3, right? For the to pick the columns of data, right? So what I don't want to do right now is deal with parsing options, because it turns out that's really awkward, right? So it is possible to parse argv to extract options from the, to extract things that look like options that you pass to your program, but it turns out to be very hard to do. It's so hard to do that there are libraries that are dedicated to do it, right? So normally, often you don't parse them on your own. So instead of using an option for cut, we're just going to pick a column to cut. So I'm going to cut the first column of data. Right, so I'm going to make a program called cut1 that cuts the first column of data from a file. All right, so if you stop and think about this for a second, how are you going to cut the first column of data from a file? You have to decide, where does the first column of data end? So here I'm going to do the same thing that cut does. I'm going to assume that the column of data ends at the tab character. So I'm going to read a line of text, or I'm going to read a file 1 character at a time until I find a tab character or the new line character. Sorry, the tab character, yes. I guess there's technically a bug in this program, but anyway, it's fine. So I'm going to read up to I see the tab character. I guess we can also check for the new line character so we can fix my bug. Right? When we see the tab character, so as I'm reading, I'm just going to write the characters back out. Right? When I see a tab character, I know that I can just read the rest of the line, throwing away the rest of the line, and then go to the next line of the file. Right? So this is basically the program I showed you all over again. Right? So in other words, it's more or less CP220. Oops, sorry. I guess I might as well just copy the entire file. Okay, so read the file 1 character at a time, right? Standard loop here. Okay, now I'm going to get rid of the error handling because it just gets in the way. Okay, so we read the file 1 character at a time, right? I'm looking for the tab character now, right? I suppose I should also look for the new line character. So if your file only has one column of data, we'll just output the 1 column of data. Right. So if C is equal to the tab character, right? So if it's equal to the tab character, I want to do something. I guess if C is equal to the new line character, I also want to do something. So let's put in that condition. And these are mutually exclusive, so I guess I should turn this into an else if. Right? Okay, so if it's not the new line character, if it's not the tab character, I just want to write the character that we just read in. Right? So to write the character that we just read in, we just do fputc. Oh, sorry. And we're going to write it standard out, just like before. Right? So read, not the new line, not tab, write. Right? Okay, if it is the new line character, that's great, right? So we basically found our column of data because we're we've hit the end of the line. So I also want to write, I also want to output the new line character, so I guess I should do that. like that. So go to write the new line character and carry, oh, but then we have this down here. So I don't want that either, right? So it looks like I don't have to handle the case of the new line. It's not a special case, in fact, right? So in fact, all I really need to do is test if the character is a tab, right? And this will work correctly even if there is only one column of data, right? So if there's one column of data, the character that gets written is the new line character. We just write the new line characters, right? Okay, so what if it is the tab? So if it's the tab, I found the end of my column of data, right? So now I need to discard the rest of the line, right? Right. So I just want to continue reading characters from the file until I see the new line character, or I hit the end of the file. Right? So how do I read in stuff one character at a time? Well, it's just this. Right, so it's that while loop all over again. I'm just going to read the rest of the line. Right? Now, if I see the new line character, right, we're done. Right, so if we're done, once we see the new line character, I can break out of this inner loop. Right, so that breaks me out of the inner loop, which puts me here. Right, which is great because I just read in the new line character. I want to write the new line character back out. Right, and so I claim that will cut the first column of data from a tab delimited file. So let's make a tab delimited file. I guess we'll use the student's example. So Bart Simpson. Oh wait, sorry. First name. Oh, let's do student number. Tab. Last name Simpson. Tab. Bart. I guess we'll do his sister Simpson. Tab Lisa, and then we'll do Ralph. Okay, so there's our tab delimited file. If I implemented cut one right, this should cut the student number from the file. Pipe in students, and there are your student numbers from the file. Right, and so there's how you can implement cut. If you wanted to cut the second column from a file, right, you just have to do a little bit of logic handling here to figure out, okay, how do I get the second column of the file, right? So I want to ignore everything up to the first tab, right? When you find the first tab, you want to start writing out as you read, you want to start writing out the characters again to the file, right? Sorry, to standard output, until you see the next tab or the new line, right? Once you see the next tab, discard the rest of the line, right? And carry on with the next line in the file. Right, so picking out the second or the third or the fourth column, you could also do, right? And then as soon as you can figure out how to pick any column from the file, you can basically implement cut. Right? It probably gets a little ugly looking, but you can easily do. Oh, sorry, it's conceptually easy to do. Okay, so what other programs did we look at, or what other commands did we look at that you can also use this pattern of reading stuff from somewhere and writing it back out as you read it? Right? And so if you remember, there was this program called TR that lets you translate text. Right? You pass it in two sets, right? Two strings. Right? Every character in the first string is replaced with the corresponding character in the second string. Right? So you read in a bunch of text. Right? Every time you see something in the first string, you replace it with the character in the second string. If you don't see the character in the first string, you just write the character that you read in. Right, and so that lets you replace sets of characters in a file. So again, if you read the character if you read a file one character at a time, you can easily implement the TR function. Right? So let's touch. So let's do TR. Again, I'm just going to start with the character-based reading a file one character at a time. And we'll just, we'll just add the extra code as needed. Okay, so TR wants the set of characters, it wants two sets of characters, right? So it wants two strings. So it wants the characters to look for, and it wants the replacement characters. So here I don't have a choice. I do need to look at the command line arguments, or I need to supply this file with command line arguments. Right, so as always, int argc, char star argv, square brackets. Okay, so I need the name of the program, I need the set1, and I need set2. So I need, so I'm expecting 3 command line arguments. Sorry. All right, so if I don't get 3 command line arguments, I should write an error message to standard error. So to write something to standard error, well, there's a bunch of ways to do it, but I'm going to use fprintf. Right. So for fprintf, right, the first thing you tell it is what file do you want to write to? Well, I'd like to write the standard error. So standard error is just standard error. Right. What do I want to write? I would like to write some sort of usage message here, I suppose. Right. So here people should call tr220, sorry, 220 with set1 and then set2 like that. New line character because it won't write one for me. Right. And then I should probably exit the program. Right. So I'm going to return 1 here. Okay, so I got 2 command line arguments. I have, I get 3 command line arguments. Remember, one of them is the name of the program, right? So I do have set1 and set2. So there are some conditions on set1 and set2, right? So remember, set1, that's the characters that you want to replace, right? Set2 is the set of characters that you will replace the characters in set1 with. So set2 has to be at least as long as set1. Right? Otherwise, there's some character in set1 that you want to replace and you haven't told it what character to replace it with. So I guess we should do some error checking here. So where is set1? So set1 is just a string, right? So it's the second string or second command line argument passed to the program. Right? Again, remember the first command line argument is the name of the program itself. More precisely, how the program was invoked. Right? So char star s2 is just the third command line argument, right? What's the condition on the first and set first? What are the preconditions on those 2 strings? The first string has to be shorter than or equal in length to the first one. So I guess I have to check the size of the strings. So how do I get the length of the string? It's just string length. I want to do the same thing for string 2. Right. Make sure, how did I write this? If length 2 is less than length 1, I've got a problem. Right? I'm replacing more characters than I know what to replace them with. So I guess we should print some sort of error message and exit. Right? So again, print the error message using fprintf, print to standard error. Set2 length. Set2 is less than length. But this is a different error. I guess we could return a different error code. It doesn't actually matter. Okay, now read in the file 1 character at a time, right? Every time I read in a character, I'm either going to write the character or I'm going to replace it. So exact same loop. I guess it's handy to have the replacement character as well. So let me change this to cin and cout. Right? So cin is the character that I'm going to read in. Right? Cout is the character that I'm going to write out. Sometimes I have to, most of the time I don't know if it's most of the time. Sometimes cout is cin. Other times cout is the replacement character for cin. Okay, so read in cin. Again, I'm going to ditch the error handling because it kind of just gets in the way. Okay, so read the file in 1 character at a time, reading the characters into cin, right? So cout, I'm just going to assume cout is equal to cin for the time being. Right? And now I want to test, is cin actually in set1? right? Because if it's in set 1, I have to replace it. So how do I test if C is in set 1? Well, there's this function called strchr, right, that searches a string for a specified character. It's inconvenient to use in this case slightly because it returns a pointer to the character, right? Chr. It would be nice if it returned an index, but it doesn't. At least in this case, it would be nice if it returned an index, right? So instead, it returns a pointer to the character if it finds the character, right? So search that string for that character. It returns a pointer to the first occurrence of cin in set 1. Right? I would like to know, I want the index of that character because I want to look in set 2 for the corresponding replacement character, right? So you can either compute the index explicitly, or you can remember that that's a pointer to a string, right? And I know what the pointer to the first character in the string is. It's just set 1. So I know that res minus set 1 is equal to the index of the character in set 1. Right? So if strchr does not find the character in the string, it returns null. Right? So if it returns null, I don't have to reset cout. If it does not return null, so if it returns some non-null pointer, right, I now need to compute cout. So cout is just the character from set 2, right? At what index? Well, at index res minus set 1. Right? So remember, res is a pointer to some character in the string, right? Start of the string's over here. Res is a pointer here, right? I know that the pointer to the first character in the string is just the name of the string. If I subtract those 2 pointers, that gives me the index that res is, the index of the character that res is pointing at. Right? So I can simply compute res minus set 1 here, and everything's fine. This is never negative, right? Because res is not null, and I know that it's pointing at some character past, either equal to or past the first character of the string. Okay, so I've now got cout, so I just have to write cout. Fput c, cout. I'm going to write the standard output, right? And we're done. Right? Compile. Oh, what did you do wrong? Oh, implicit declaration of the function string length. Okay, so the compiler is telling us it does not know what string length is, right? Where is string length declared? It's declared in string.h. So include string.h. Recompile. Everybody's happy. Okay, so we want to translate one character to another. So somewhere I have alphabet, right? Oh, I don't have alphabet here. I do have some file. Okay, so let's replace some of these characters with some other characters. Okay, so give it set 1. So let's replace the, I don't know, the FG and H. FG and H. They don't have to be side by side. They can be anywhere, right? So let's do the F, the J, and the N with their capital replacements. Pipe in the file that we want to replace, so some file. And there you go. Right. So the F gets replaced with the capital F, the J gets replaced with the capital J, the N gets replaced with the capital N. Right. And away you go. All right, the next example is slightly longer than the last one. So I think we'll wait till the next class to do that one. So the next one, we're going to implement reverse. So I don't remember if I asked you a question that used rev. So remember, rev reads a file, one line at a time. It reverses the characters, the order of the characters for each line. Not the most useful program in the world, but it exists, and so we'll implement that one. That one's trickier. Because here you really do need to read in complete lines to reverse them, right? I can't read in part of a line and reverse part of the line. I have to read in the entire line. So that complicates things. So we'll have to do some dynamic memory allocation to solve that problem. So that's for Monday, I guess. And I do promise you will get your midterms back on Monday. So they're coming back on Monday one way or another.